new chapter on design for timber beams and also for the columns. Okay. So if you can see in the order, I had uploaded all the notes for the timber and also Malaysian standard. For the timber, we will refer MS544 Malaysian standards, especially for part 2, okay, whereas all the design according to MS544 part 2. So this part 1 slide here is just introductions. Maybe I can go through not so in details of this part 1, which is you can read it by yourself. Okay, but what you need to know here that what is timber is, okay, if you look at in this first slide, this is all about the advantage of use timber as construction material, which is timber has low density, okay, is more lighter compared to the steel, compared to the concretes, okay. At the same times, it has height strength and also stiffness, okay. Means of this low density, height strength and height stiffness here offers a structure efficiency, okay, as a construction materials compared to the concretes. Timber either natural durable or can be treated to make it durable. So that means some of it not so durable because of, as we know that timber has many species, right? Especially in Malaysia, we have a lot of species for the timber. So some of it not so durable. So that means there will need some process or treatments, okay, to enhance its durability. Then timber has low thermal conductivity, provide energy efficiency in the building. So low thermal conductivity. Kalau rumah kayu tak panas kan, sejuk je. So that is signs of how's the thermal conductivity of the timber. Okay, so timber construction materials can be installed efficiently, save times, labor and cost without having the need to rent heavy equipment because of this low density, right? It's easy to assemble, to transport, to install at sites, right? So timber is environmental friendly. Of course, is greens and natural sources, right? Which reduce carbon emissions compared to concrete. Okay, which one of the main source of carbon emission, which is cement. Okay, so by using of this timber, we can reduce the pollutions, but at the same time, we also need to preserve our natural sources. Okay. So timber can be categorized into two types, softwood and hardwood here. How to differentiate or recognize which one is softwood, which one is hardwood by observe of its physicals, okay, especially on its leaves. So kalau softwood, dia punya daun is like a needles, okay. Kalau hardwood is more broad leaf trees. Okay, for softwood grow faster rate than hardwood, so that means it's easily to find in the market, okay, because it takes about just few years for growing compared to the hardwood. The growing rates more slower, which produce thicker diameter, right, for the timber than softwood. So it's quite limited additions, quite expensive. Because of its growth slower, it also produce stronger, more stronger compared to the softwood. So this is an example which has a broad leaf here, okay, bigger compared to this like needles leaf here. This is hardwood, this is softwood here. So then by looking at its cell structure also you can differentiate which is hardwood has a pore or vessels inside it compared to the softwoods. So if you look at this is all the cells here that can be considered how many years for that trees. So for one cells here, okay, one row of cells is it represent for 1 year of growing. That is how we can know the age of the timber, okay, compared to the hardwood and softwood. So in Malaysia, hardwood can be divided into 3 groups here, which is heavy wood, medium, and light hardwood. Okay, according to its density. So heavy wood has a density higher compared to other types. Okay, so softwood, of course, has a density lower than all of these hardwood here. Okay, so because of a high density, that means it's more stronger. The hardwood's more stronger compared to the softwood. So especially for the heavy wood and medium wood here, it suitable to be used as a constructions materials, such as for columns, for beams, or for foundations that is suitable to be used to use heavy and medium hardwood. Contoh balau, cengai, merbak. If you familiar with these names, okay, with these species, kerwing, mengkulang, tualang, all of these grouped in the heavy and medium hardwood, while the rest can be in light hardwood or softwood, which is light hardwood and softwood generally used for non-structural part. Okay, contoh for the furniture, for window, for what else? For door and everything lah, which is not structural parts. Okay, at the same time, timber also have its weakness, especially defects of its natural defects here. Okay, that we call it as a knot here, kan? Which is this knot can reduce the strength, can reduce the properties of the timber. Okay, kalau lihat kayu kan ada nampak macam apa ni kecacatan kat sini. So this is the defects of the timber, and also other defect is the vein here. So it looks like some part of its apa ni have a reductions of its cross sections. Okay, and then also have a cracks here. Okay, so this also can reduce the strength for the timber. Then other timber defect is from the seasoning process, which is the process where the moisture of the timber is reduced. So that means during the drying process. So you need to understand here that dry timber is more stronger compared to the wet timber. Okay, the timber has 2 conditions, either in wet condition which has a high moisture content, and another condition is a dry timber which has a low moisture content that give high strength, okay, to the timber. So that means during the seasonings process or during the drying process, timber will experience of this kind of defect. So either serious or not. So might have a bowing here, cracking, scooping, and also twistings, which can affect the strength of the timber. So for the material properties of the timber, we concerns about its density. How lighter that timber, what's the density of that timber? It's mainly determined by the amount of wood substance and water contents. Okay, what's the moisture content in the timber? So greater density means higher mechanical properties in terms of its strength or in terms of its stiffness here. Okay, which is you can read it. Okay, and then shrinkage here. So this shrinkage here, of course, will reduce the dimensions of the timber. It's happened during the drying process, kan? Dia macam mengecut gitu. Okay, which reduction of its size for the timber. What else? So shrinkage or can affect the timber strength, stiffness, and also durability. So then this term that we call it as a anisotrophy is about the directions of the grain. Kalau dalam bahasa Melayu, era kayu. Era kayu. If you look at on the surface of timber, you can see these kinds of grains, right? So these grains can be in different directions, right? Okay, so that's why we call it as an anisotropy here. So which is because of different orientations of this fiber, orientation of this grain also can give a different strength for the timber. Okay. So if you look at here, this is a longitudinal. That means the strengths parallel to the grain's directions. Okay, that will give a different strengths compared to the perpendicular directions. Okay, let's say the strength of the timber or modulus. Okay, strength, modulus, or any tension, shear, compression, which is parallel to the grain direction, is different to the strengths or material properties that is perpendicular to the grain's direction. Okay, then hygroscopic. So it means ability to attract water from atmosphere. As we know that timber have conditions, as the conditions is it high moisture content or low moisture content. So it depends types or species of that timber, how it can absorbs all the water. Okay. Which is this moisture content will affect the strength of the timber. Okay, then fire. The durations for that structure that made of timber can resist the fire. So if you look at this is cross sections of the timber. Okay, yang dah yang dah jadi arang kan, which is a char layer here. So the charring rate for timber is around 0.6 millimeter per minute. It's quite fast. Okay, it's quite fast. Need for the burning process for the timber. So that's why most of building codes limit the use of timber. Okay, in particular number of story of timber buildings. Okay, so this is what I mentioned about the parallel to the grain, which is the strength and stiffness parallel to grain is strongest compared to the strength and stiffness perpendicular to the grain. So this is what is mean the strength and stiffness that we calculate parallel to the grains, while this is the stiffness or strength that we calculate perpendicular to this strain here. Okay, so it noted here that the tensile strength of softwood parallel to grain range between 70 to 150 megapascals. Okay, once it's compared to this perpendicular to grain here. Okay, you can see all the data here, which is the strength and stiffness quite lower compared to the strengths of timber parallel to the grain. All right, so in timber, because of has many species, ada yang you familiar, some of it you baru dengar atau you nampak ni nyalin, perupuk kan. I also not familiar with the species of the timber. So that's why the Malaysian standard MS 544 here grouped the timber which has similar properties, similar appearance, similar strength in one group. Okay, let's say SG1 consists of balau, bitis, cengal, penaga. Kalau dalam SG1 saya selalu dengar balau, cengal kan. So SG2, so this is all the species that it's grouped in SG2. So you don't have to remember this because all of these tables included in the Malaysian standards. Okay, because some of the questions mention about the SG, which is the strength group here. Okay, SG stand for strength group. Let's say for SG1 more stronger than SG2, more stronger than SG3. Okay, when we talk about the strength, so some of the questions it mentioned about the strength group. So that's mean you have to refer. Let's say SG3, what the strength or stiffness for the SG3. Some of the question it just mentioned about the species. So that's mean you have to check in the tables that species grouped in what SG. Okay, let's say you have to design the beam that made of babai kan, spesies babai ni ada pula spesies babai kan. So you have to refer in the table what's the SG for babai species. Okay, that is for example for SG. Okay, and then this is another table. Actually there's a lot of them tables you can see in the Malaysian standards. Okay, for the timber, this is just to show that how we refer SG to know its strengths. Okay, to know in order to know the properties of that SG. Okay, let's say for SG1, is it in wet condition or dry condition? As you can refer in these tables, it's noted here that the moisture content for wet condition, once it's moisture more than 19%. So kalau dia punya moisture content less or equal to 19%, it considered as a dry timber. Okay, is it wet timber or dry timber? Normally it would be mentioned in the questions. Okay, so you have to bear in mind that that's for the final, mostly usually will included the timber designs. Okay, will included the timber designs. So that's mean we you have to design the concretes and also to design the timber structure. Okay, let's say SG1. wet condition or dry condition. So there are two values here according to its conditions. And then the top of the columns here, it label about its strength actually. The first is the bending parallel to grains. Okay, remember we have a strength, is it parallel or perpendicular to the grains? So for the bendings, it gives a parallel to the grains value. Okay, for SEL, STD, COM here is a actually is a select structure, standard structure, or common structure. You can also see the notes in these tables here. What types of that timber? Is it selected timber, which give a high bending stress compared to the standard timber, compared to the common timber? So it's about the quality of the timber. But normally for the design, for the nation design, we use for the standard timber. But either selected or standards or common structural timber will be given in the question. Okay, either you have to use selects or standard or common structural timber. Okay, so this is a bending which is parallel to the grain. So this is how the symbol, which is moments, right, for the bendings. And then this is symbol parallel to the grains. This is the tensions, which is parallel to the grain. This is the compressions parallel to the grain. This is the compressions. It gives a two value for parallel and perpendicular. So this is perpendicular to the grain. This is the shear, which is parallel to the grain, while this is E, which is modulus of elasticity. Is it as a mean? You have to refer E mean, or you also can refer E minimum. So it shows here that the total for the SG is 7 here, okay, from SG1 up to SG7. Okay, so this is overview of the applications, either as a structural component for the column, beams, joists, and everything. Okay, and also for the formwork. So this is the suitable strength group can be used. Let's say for the column beam, so boleh guna SG1, boleh guna any species or any timber that is grouped in the SG2, 3, and SG4. Okay, kalau roofings for rafter or batten, so same, which is can be used SG 1, 2, 3 up to SG 4. Okay, finish for part 1. We go for the part 2. Alright, so commonly timber used as a beams, okay, and also as a joist here. So you need to understand the differences between beams and joists. Okay, so if you look at this picture here, this is the main beam. Okay, the main beam. Whilst the ones that has closest spacing here, can this is, we call it as a joist here, whereas this joist was which is on top of this joist will arrange the slabs. Okay, so it will support the slab. The beam and joist will support the slabs here. Okay, but it has more closer spacings. Okay, for this joist, and also for this roof systems. Okay, which is, you can see here, this is the main trusses. Okay, this is the main truss. This is the main truss. Okay, before you can arrange the roof tiles, the metal decks, you have to arrange the batten. We call it as a batten or purlin, which more closer spacings. Okay, short spacings um, for the batten or for the purlin. So same goes for these joists here. Okay, so that is the difference between beams and joists. So some of the Christians you have to design the beams, and some of it you have to design the joists. But how the process is the same here. Okay, because this is a structure or part that will support the slabs on top of it. Okay. um, all right, so in terms size of timber, it can be governed by Z's here, okay, which is elastic section modulus. Cross sections, what's the BD of the timber, okay, and then second moment area, which is BH BH power of 3 divided by 12, right? So this is how we govern the size of the timber according to the Christians. So some of it you can just refer in the tables about the cross sections, about the area of the timber, and according to the cross section or size of the timber, in the tables you also can just directly determine its second moment of area or elastic seconds modulus. Okay, these two term of sawn timber. Okay, either that timber is not smooth or smooth enough. Okay, the first one here, which we call it as a rough sawn or full sawn here, this timber is not dressed or surface, which is it's still rough surface. um, the dimension is oversized to allow for shrinkage and before fully seasoned. So that means it's still raw. It's still after we cut the timber according to the desired size, that is we call it as a rough sawn or full sawn. But after the timber has been dressed by smooth surface, uniform dimensions, we call it as a dress on surface timber, which is dress timber. So of course the dimensions is reduced, right? Okay, the dimensions smaller compared to the rough sawn or full sawn timber. So for all of this sawn timber here, is it a smooth or not smooth surface here can be referred in table B3A or 3B and table B4. So you need to refer these tables. Okay, you have to be careful. Some of the timber according to the rough sawn, some of the timber according to the dress timber. Okay, and then also some of the timber according to the moisture content more than 19%, which is wet timber. Some of the timber according to the dry timber, which is less, the moisture content less than 19%. So this is examples timber. Okay, tables according to its geometrical properties of sawn timber at 19% moisture content. Once it says at 90% moisture content, so that means this table refer to dry timber. Okay, because once the moisture content is less or equal 19%, it considered as the dry timber. So wet timber, once the moisture content more than 19%. So if you look at of this timber, it has a nominal size and then minimum size and then its area, and then it give a second moments area, which is it's already give a IXX and also IYY, right? So this axis, is it ZXX or ZYY or RXX, RYY, normally used for in terms for the columns, and in terms how we arrange the timber. Is it in this direction or is it in this direction? Okay, with the same size. So it will give a different strength, right? Okay, so before I go to these slides here, let us see what is inside in nation standard first. Can you see I change the slide to be as a nation standard? Can you see my nation standard slide ni? Hello, ada orang ke tak? Can you see this nation standard slide?
Yes, yes.
Ada orang punya kan. Okay, so relation standard have a two part. This is the part one. Okay, so you can see it's all the determinations of select, standard, common. What is the great stress here? Okay, mostly all the determinations included in part one here. Okay, and also about the moisture contents. So you can see here the moisture contents with various applications. Okay, let's say for the flooring, it should be about 19%. Most of the structure here. Okay. Alright, so this is another about the modification factor, which is we will go through on this modification factor. There's a lot of K here that you need to refer. Don't worry, not so difficult actually to design the timber. Alright, so then we go for part 2 here. Okay, for the part 2, it's more into designs. So all the tables will be referred in this part 2. So it starts with the table 1 here. Okay, referred to its title of this table is on wet. So that means this is the wet timber. Okay. Korang nampak ke? Okay, so this is the wet timber. With moisture content more than 19%. So if you refer according to the species of that timber, kata dalam soalan dia mentions use cengal, let's say guna cengal kat sini kan, so you have to refer in this table because it's according to the species of the timber. So cengal with moisture content 19% or cengal with the wet timber. Okay, so what's the strength of its bendings, parallel to grain or tensions, compression? Is it selects or standards or columns types here? So if standard, so that means the value for bending parallel to grain is 24.9, which the modulus of elasticity, if E mean, which is 18/100 here, ataupun E minimums. Okay, so that is how we refer the tables. Then we look at for other tables. This is if you look at for this table 1, it keep continue until the last is a tualang, about 94 species okay, that is considered in the designs here. So that means uh, the all of these 94 species also has a dry timber which moisture content less than 19%, which you can see in this table too. The species is repeated, but this value according if that timber in dry conditions, okay, with moisture content equal or less than 19%. So you can see the 94 species, right, which is again tualang, but the value according to its dry conditions, okay. So then as strand group, which is SG, okay. Let's see the question it mentioned about SG, okay, dia tak sebut pun apa ni, tualang ke apa semua. Kalau dia sebut tualang, so you kena cari this is grouped in SG3 for tualang species, okay. So SG3, so that means you have to refer SG3, okay, in order to know what's again the bendings, tensions and everything, okay. Alright, so for SG it divide into two lah, wet and dry. So if you compare the SG value here according to the SG, and if you compare, let's say for the tualang's value, there will be a slightly different value because once we refer generally on it SG, the value is not exactly, okay, compared to this one. Okay, let's say for tualang, for the dry conditions bending, right, which is 25.7 for select. So look at for SG3, that is for tualangs, right, SG3 here. Lihat table ni SG3 tualang which is dry, right, so bending is about 20.2. Okay, 20.2 is slightly different once we refer as a general strand group compared to its specific species. Okay, so that means it depends the question. If mentions tualang, so you have to go into it details on the tualang. So use of this 25.7. If just the generals of SG3, so this is the value you have to refer. Okay. So you can go through all the mentioned standard here. Then we move on to part 2 slides here. Okay, so this is the notations that you need to know for the designs. Okay, there are three notation here according to the type of force. Kalau compression, this is the symbol C. Bending guna symbol M. Tension guna symbol T. So significance, which is what's the significance of that value? Is it for grade, let's say grade strength or applied strength? So kalau applied A, okay, so all of this symbol for permissibles, especially once we do the checking, okay, we have to compare with the permissibles. The symbol for the permissible is the ADM, and then effective E. Okay, so this is for the mean. And then geometry, we have two directions, right? Is it parallel or perpendicular to the grain? So this is how the symbols for parallel, while this is the symbol for perpendicular to grains. So once we listed all these notations, which is these symbols is a symbol for what? Symbol for apa ni? This is for the stress, right? So M here is a symbol for the bending. A is a symbol for the applied. These symbols is considered as a perpendicular to grain. Okay, so that means you have to mention this notation as the applied bending stress. This is applied bending stress perpendicular to the grain. Okay, which is perpendicular to the grain. So let's say you buat lain, this is like, let's say parallel. So how to mention this notation, which is applied compression stress parallel to the grain. Okay, so that is how you need to understand on how to what is meant by this notation. This notation we will use in the designs. So grade stress, this is the grade stress here. Okay, this is the grade stress here. So defined as the stress which can safely be permanently sustained by material or specific sections of a particular strength class that is can be referred in this table 1 to 4. Yang tadilah you all tengok tadi tu. Bendings, tensions, everything that is a great stress. Okay, is a great stress which is also a particular strength for that timber according to its size, according to its species. Okay, so there are three grade, which is select, standard, or common grade. Okay, which is the first one, which is select, less defect. So once it less defect, that it's more stronger. Okay, so again depends on the question. If it mentions standard, you have to refer the standards value, okay, for the timber, or select or common types for the timber. Okay, this is the table. So okay, right. Then we go for permissible stress. Okay, for the permissible stress, this is we have to do the comparison with the permissible stress. We have to check, is it that applied stress is less or more than the permissible stress? Okay, so this is the this is the list for the checkings of permissible stress. We need to do the checking for flexure, strength, shear, banyak kan, bearing, laterals, and deflection. So all of these 5 checking for the permissible stress here. I think I skipped. Okay, so in design you have need to know what the applied stress for that timber and also what the permissible stress for that timber according to its species, according to its types, according to its sections, the size for that timber. So applied stress, it means what is the real loading or real stress that applied on that structure. What permissible stress, what's the capability of that beams, what the capability of that material to sustain, to resist all the stress that applied on it. Okay, so this is a formula for permissible stress, which is ADM, right? Dia punya notations. Seems that I will lose my connections. Can you hear me?
Yes, yes.
Yes.
Kejap lagi lost lah ni kan. Okay. This is the equation for permissible stress, which is grade stress. Grade stress yang daripada tables tadi. Apa bending, apa compressions, tensions and everything. You have to multiply with the modification factor, which is K. This K have more than 1K. Okay, more than 1K that we will Okay, nampaknya begitu ya. Saya off kamera. Okay, I share balik. Can you see my slide?
Yes, Doctor.
Okay, so I balik semula sikit. Okay, so applied stress must be compared with permissible stress. This is the equation for permissible stress, which is grade stress. Grade stress yang tadi tu daripada tables 1, 2, 3, 4, is it wet or dry, what the bending parallel to grain or compression, perpendicular to the grain and everything. So you have to multiply with the modification factors. So modification factors here, ada 6 kat sini. If we refer to the beam design, actually it's more than 6, but for the beam design, we just refer of these 6 modification factor. K1, K2 up to K6 here. So you have to understand the modification factor here, the K value here one by one. The first one, K1, is about duration of loading. How long the services for that structure. Okay, how long the lifetime for that structure. Long duration or short durations. Okay, so that will give you the value for the K. And then load sharing system. Is that structure have a sharing system? That means it just stand alone, macam suspended dengan non-suspended slab. Macam inilah juga load sharing system. Is it any sharing system or not share with other structure? So that will give the value for the K2. Bearing stress, it about the area for the support. Okay, and then shear at notch end. Notch end, that means kalau you nampak kayu kan, ada dia punya apa ni, connections macam ni. Okay, with the columns. That is what is mean by notch. Ada yang notch top or bottom notch here. Okay, some of the section will be cut here in terms actually for the connections. Okay, so this is what is mean by notch. Some of the timber just use as a full section. There's no notch here, so it will give a value for K4. Is it that timber has a notch or not? Okay, and then form factor. Form factor is about how the the shapes of that timber. Is it circular or rectangles or square? That is for K5. And then depth factor. So what the depth factor of that timber. Okay. Okay. For K1, which is modification for durations of loading, have to refer table 5. Okay, so if I shows you in nation standard, it will in page 20 here. Okay, for the table 5. In these tables, okay, if I make it bigger, so you can see different duration of loading, long term or medium term, short term or very short term. So that's mean K1 kalau long term, so K1 is equal to 1. That's it. Okay, medium term, K1 is equal to 1.25 and so on. Okay, that's for K1. Then we go for K2. It's about load sharing system. So kalau tak ada sharing, no sharing system, it just simply supported timber beam that stand alone. There's no continuous with other structure. So that means K2 is equal to 1. it's no load sharing system. Okay, that means for the E or modulus, you have to use E minimum. We have two E, right? Either E min or E minimum. Kalau K2 is equal to 1, which is no load sharing, so you have to use E minimum. Kalau ada sharing, okay, you have to use K2 is equal to 1.1. Okay, that means you have to use E min to calculate deflections and displacement here. Okay, so what is meant by sharing here? So you have to also check if the number of element is 4 or more, okay, and the distance between element or spacing is less than 610. So that means any besides any the nearest elements of that structure with the spacings less than 610 and the element is more, which is 4 or more, so that can be considered as a sharing system. If not, just consider as a K2, which is no load sharing. So if you look at of these examples, okay, let's say this is the structure that you have to design with the spacing here. Okay, this is all the joists here. This is the floor joist. This is the flooring systems, right? So all of these elements which more than 4 or 4 or 4 or more than it. Okay, so ni ada element, this is first, second, third, fourth, which is more than 4, right? And then the spacing of each element is less than 610. Okay, so this can be considered as a K2 is equal to 1.1, which consider that has a sharing system. Then K3 is about the bearing stress or support actually. Okay, look at of these two conditions here. Okay, for bearing length, this is what is meant by the bearing length. So the area of the support here, this is the bearing length. For bearing length less than 150 and located 75 mm or more from end of member, you have to use table 6, okay, for the value of K3. So if you look at this is the support, right? Which if the bearing length less than 150. Sekejap lagi I akan lost lagi there's a signs of lost connections. So if 150 and less, and then about 75 mm, this is about the hanging regions. So you have to use table 6. This is the table 6, which is length of bearing. You nampak dia sampai 150 saja. Kalau kurang daripada 150, you have to use all of these kinds of K3. If more than it, so K3 is equal to 1. So this is 150, which is 150 or more than it. So mungkin cuaca tak elok kan, baru lepas hujan ni, so mungkinlah internet office tak begitu baik. Okay, can you see my slide?
Yes, doctor.
Alright, letih kan begini. Okay, so that means you have to refer the bearings length. Okay, is it use this table 6 or just K3 is equal to 1? Then we go for another K, which is K4. So K4, kalau timber ada notch, kalau tak ada notch, just K4 is equal to 1. Okay, so in terms of notch here, it has two conditions, either underside notch ataupun top notch. This is the effective height for the notch, okay, HE. Okay, and then this is A is the distance, okay, from this notch to the support. Okay, so for underside notch, you just need to use of this equation, which is HE divided by full depth of the timber. Okay, in order to know the value for the K4. Kalau top notch, so you have to determine its A dulu. Is it that A is more or less than HE? So this is the distance for the A. Okay, so then you can use of these equations. Okay, then K5, K5 senang je, is about the shapes of that timber. Kalau rectangles, so you have to use K5 is 1.0 rectangles. Okay, so for other shapes, okay, circular sections, if circular, K5 1.18. Kalau solid square, kan, ni sama, ni semua sama, ni size, so K5 1.41. Okay, that is for the K5. So you have to remember what is K1 for duration of loading, what is K2, what is K3, K4, K5, okay, sampai K6 this one. So K6 is applied once the depth of the timber more than 300 mm, which is you have to use of these K6 equations, okay, in order to consider the modifications. Okay, kalau dia H dia ni, which is this H, let's say the H is equals dia punya depth of beam is just about 250 mm, which is the H not, which is less than 300, right? So that means K6 just equal to 1. So kalau H, which is about 500 mm, which is the H more than 300 mm, you have to use of these equations, okay, to know the K6 value. Okay, just replace 500, okay, in order to know the ratio for this K6. Okay, then another checking is about the lateral stability. Okay, so which is you have to do the proportions, okay, between the depths and also the B here. So that's mean this is the ratio for H divide by B. Okay, kalau you punya H divide by B dapat nearest to 2, that is that means no lateral support. If nearest to 3, that means ends held in position for that structure. Okay, then we go for part 3. So dalam part 3, it listed all the equations, okay, that you need to use. Okay, first you have consider about the bendings, right? So this is how the equation for the bending, that you have to compare with the applied bending stress with the permissible bending stress. So that means there will be two equation for applied and also equation for the permissible bending stress here. So remember about this notation. Right, so this is applied, this is bending, this is the stress, and this is parallel to the grain. So that means you have to use permissibles also parallel to the grain here. Okay. So for the applied is about the real moment that applied on that beam. So what's the moment of that beam? Okay, you have to divide by z here. Okay, and then for permissibles, this is the grade stress. Okay, you have to multiply with this all of this modification factor. Okay, K1, K2, K5, K6, not K, not all K, right? We have it missing here K3, K4. So that's mean to calculate the permissible bending stress, it consider K1, K2, K5, and K6. You have to multiply with the grade bending stress, which is parallel to the grain. Okay, parallel to the grain. This refer from the table. Daripada table, you kena lihat lah. Sekejap tunjuk table. Mana table tadi? Okay, sini. This is what is mean by bending parallel to the grain. Kan? So this is a bending which is parallel to grain. So kalau tadi dia nak perlukan stress. So this is the value for bending parallel to grain. So just use of this value, okay, replace in these equations. Then multiply by K1, K2, K5, K6. So must satisfy. Okay, applied should be less or equal than permissible stress here. Okay, then same goes for the shear. You have to calculate the applied shear first, which is 1.5 V divided by A. Okay, then you have to compare with ADM, which is permissible shear stress, which is parallel to the grain. So you have to check in the table, use the correct value for shear grade parallel to grain. Okay, kalau I pergi balik dekat table, so this is the shear parallel to grain. Okay, whereas the value should be referred. Can you understand me? Any questions? Dah lost connection ke? No questions. Okay, alright, so again you have to satisfy the applied should be less or equals than permissible. Okay, sama juga macam bearing here. Okay, this is for the bearing, which is this is equations for permissibles. So what's the for the bearing, you have to consider, if you look at here, okay, you have to consider the stress for the compression value perpendicular to the grain. Okay, so if I refer back in the table, kita ada compression parallel and compression perpendicular. This is value for perpendicular. Okay, so don't do mistakes on this. Okay, we have because we have two parallels and also perpendicular, especially for the compressions. Then you have to compare with the actual or applied bearing stress, which is stress is equal to P divided by A, which is the area of the timber. Okay, then this is lateral stability, which is you have to refer to tables. Okay, this is about H divided by B, just a ratio, and and then you have to refer table 7 in order to know what's the conditions for that timber. Then checking for deflections. Okay, so checking for deflection is total of deflections on bendings and also deflection for the shear, which is it should be less or equal to 0.003 multiplied by its span here. Okay, multiplied by its span here, or less or equal of 14 mm. So you have to calculate what's the deflections in terms of bendings and what's deflection in terms of shear. Okay, so this is equations for deflections in terms of shear. Okay, just replace what's the value for the moments, the area, and then the modulus of elasticity for the E min. Okay, so this is the deflection according to the bending here. Okay, what's the bendings if the beams is loaded as the uniform? What's the bendings? What's the deflections here? Which is this is deflections according to the bending. This is all the deflections according to the bending. So just use of this formula according to the load that apply on it. Is it uniforms or point loads? Kalau point loads, is it exactly at the center or have a proportions here? Okay, or rectangles or triangles, uniforms load. So so to make sure that you understand, we go for the examples. You want to proceed or take a break? Nak proceed atau take a break? Proceed. Okay, takut lost connection lah tu. Okay, look at these examples. Okay, this is the main beam with 3 meter length spans. Okay, so dia dah bagi all the details for its length here. Okay, from surface of the columns to the surface of the column, that means this is the clearance. Okay, so this is the clearance, and then from center of column to the center of column is 2850. 2850. So that means this is 25, and also this one 25. Okay, so the beam support a flooring system. So that means there will be a flooring system on top of it which exerts a long duration loading. So dia dah bagi sini data about long duration loading. This is consideration for K1, right? Is it long duration or short durations? Kalau long duration, kalau tengok table, is about 1.0. Okay, dia punya modifications factor. This is the loading, which is 3.9 kilonewton per meter, which is uniform loads along the length of the beam. So which is this 3.9 including its own safe weight. Tak payah kira lagi lah. This one already include its safe weight. The beam is supported by 50 mm wide walls on either side. So if you look at this is about the bearing that you need to consider about the bearings, right? Is it the support here 150 or more than it, and then this is also, is it 75 or less than it, right? Okay, carry out design checks to show that this size of the timber beam, okay, it mentioned about the deep sawn sections of strength group 4, which is this is SG4 of timber at 19% of moisture content at 19. So that means this is the dry timber. Okay, dry timber with standard grade. Standard grade, we have 3 types, right? 3 grades: select, standard, or common. So this beam is a STD, is a standard grade. So you see, we have a lot of informations that you can relate with the designs process for the timber. So of course you have to extract all the data, what the clear spans, which is 2800, the bearing length, okay, which is, this is the bearing length, which is 50 mm, that fully supports by the columns. Oops. Okay, and then effective length, which is from center to center of the columns. So this is all the beam dimension, which is from this beam dimension, you can calculate its area and also calculate its IXX. Okay, calculate the IXX by use of these equations. So it's applied, it's a uniform loads applied on it. And then you can list out all the K that is related to the conditions, to the situation of the beam. We have K1 up to K6. So K1 is about the durations, right? It's about the durations. It mentioned that the beam is a long duration. So that means K1 is equal to 1. K2 is about the sharing system. Is there any sharing system for this beam? Okay, is there any sharing system? We couldn't see any other element. We can't see any other structure beside it. So that means no load sharing system. So senang je, K2 is equal to 1. And then K3 is about the bearing stress, right? The bearing stress. So dia punya bearing stress tadi, this is the bearing here, okay, which is 50 mm. And then dia punya overhanging, this one also 50 mm. So bearing is 50 mm, okay, but located less than 75 mm from end of member. So we couldn't say that we couldn't use table 7, right? Is it table 7? I tengok balik kat bearing. Okay, table 6. Kalau apa ni, it fulfill, if it fulfill of this one, you can use of table 6 here. Okay, which length of bearing up to 100 here. Kalau length of bearings is about 100 or more, okay, so you can just use K3 is equal to 1. So that's why K3 is equal to 1. And then there's no notch for this beam. Lagilah senang kan, there's no notch. So K4 is equal to 1. Then this is a rectangle sections. Okay, rectangle section. So for the rectangle sections, the K5 is 1. Kalau circular tadi 1.18. Kalau square 1.41. Because of this rectangle sections, so K5 is equal to 1. Okay, and then K6, the beam depth less than 300. Berapa dia punya beam depth here? 190. 190. Okay, which is less than 300. So just use K6 is 1. Kalau H more than 300, so you have to use equation for the K6. Okay, you have to use formula K6 in order to know the value for the K6. Kalau tak, so just 1. So nampak kat sini, at last, finally, all the K is just 1. Okay, so that is how you need to list all the K factors according to the conditions for the timber beams.
Doctor,
Yeah.
can you explain again for the K3? I don't understand.
Okay, for this K3, so you look at, okay, I pergi balik dekat notes. Okay, kat sini Okay, for bearing length less than 150 and located 75 mm, okay, or more from end of member, K3 should be determined according to table 6 here. Okay, so look at of this figure here. Kalau bearing length is 50, which is less than 5150, okay, so it should be okay, this should be less 150. Do some clear notes, right? This is not so clear. Dia punya descriptions. Okay, if less 150 mm and then dia punya hanging is 75 or more than it, you can use table 6. If not fulfill this one, so K3 is equal to 1. Okay, so kalau guna table 6 here, which means dia punya bearing here is less than 150. So might be nearest 100, 75, 50. Okay, but at the same time, the hanging here is within 75 and more. So you can use of this value. Okay, if the bearings more than 150, which is this one, 150 or more than it, so K is equal to 1. Right. So look at again the situations for this okay, for this bearing systems. So this bearing is 50 mm. So this fulfill the first term, right? Which is it should be less than the bearings length. The bearings length should be less than 150 mm. But these hangings here is less than 75. The hangings length here, it should be 75 and more. So that's mean you don't it's not not fulfills the requirement, okay, to use the table 6. So that's why K3 just use 1.0. Okay tak?
Okay.
Okay, so just betulkan note ni, might be it's confused, right? Note ni should be less. Okay. Boleh pula. Less 150. Okay. Alright. So dah ada semua, okay. And then this is all the grade stress also you have to list out, okay, which is the bendings parallel to grains, which is this is the bending parallel to grain, the compressions perpendicular to grain, which is the compression perpendicular to the grain, and then the shear parallel to grain, the shear parallel to grain, and E minimums. Is it either E minimum or E min is according to the K factor, right? Which is if K is equal to 1, so all of it have to use E minimum. Kalau that K have a, you have to refer the tables, have a value other than 1, you have to refer E min. Okay, so this all the value is from this table 4. Okay, because in this example it mentioned about SG4. So SG4, so you tak payah tahulah this species balau ke, cengar ke, meranti, so you don't have to know that. So just use this strain grade group 4 here, okay, which is group 4, and then it's dry condition because it mentioned the moisture at 19%, okay, at 19%. Even it never mentioned is it wet or dry, but once it mentioned at 19% it moisture content, that's mean is dry conditions. So SG4 dry conditions, and then standard grade, okay, standard grade. So that's mean you have to refer all the standard value, okay, all the standards value. So that means bending spiral to grain is 13.2. So compressions perpendicular to the grain is 1.64. Okay, so just extracts from this table, okay, because you will do the checkings for bendings, checkings for the compressions, which is this actually checking for the bearing, and then checking for the shear for timber beams. At the same time as actually also checking for the deflections. Okay, so do the checking for bending stress, which is you have to calculate its applied bending stress first. Okay, so applied bending stress, which is moment divided by Z xx here. Okay, what's the moment for that beams? So which is you can refer kat mana tadi? This one's right. So you can use of this equation. Okay, maximum bending kalau dia simply supported lah, which is WL power of 2 divided by 8 here. Okay, in order to calculate the bendings. The applied bendings divided by Z. Okay, so Z is equal to BH power 2 divided by 6. This is the applied bending stress. While this is for equation for permissible bending stress. So this is from the tables. Okay, this is from the tables, which is 13.2. This one 13.2. You have to multiply with all the modification factor that related to the bending stress, which is K1, K2, K5, K6. Semua ni satu kan, which is 13.2. So do the comparison between applied and bending. It shows here that the applied bending stress is less than the permissible bending stress. So that means satisfy the checking for bending stress. Same goes for the shear stress. What's the applied shear force, and then you have to compare with permissible shear stress. Okay, so this is from the tables, and then multiply with all the modifications factors. So compare between applied and permissibles. Then bearing also, okay, which is stress is equal to load divided by area. Okay, so this is area for the bearings. Okay, that's mean this is the cross sections that supports the beams. Okay, So dalam soalan tadi dia punya columns width is 50 mm. Okay, and then the beams here. Okay, the beam is 70, 90, right? Okay, so that means the beam will be loaded at 70 here. So that's why 50 multiply with 70. Okay, which is this column will support of this beam here. Okay, you have to compare with permissible bending stress. Is it satisfied or not? Okay, do the checking. Okay, for lateral stability, just divide H divide B. H divide B. What's the H of the beams, and then divide its B. So the value is 2.71, which is nearest to the 3. Refer the table 7. So it give look at of table 7. So this is table 7 about the lateral support, which is H divided by B. So dapat tadi 2.7. 2.7 nearest to this ratio, which is 3. So that means that beam is ends held in positions. So just need to know what's the lateral support for that beam. Okay, then deflections here. So deflections, we have two total deflections in terms of bendings, and another one deflections in terms of the shear. So you have to calculate deflection bendings, you have to calculate deflection to shear. To shear ni betul kan This is shear S. Okay, so totals deflection bending 11.02 plus 0.75 for shear here, which is 11.77 here. So you have to compare with the permissible deflections, which is permissible deflection is 0.003 multiply with the L effective. Okay, so do the comparisons. It shows that the deflections total, which is the actual one, more than the permissible. So you can do the command, which is hence the deflection of the bending at the beam is unsatisfied. Okay, that's the deflections is more than the permissible. Need to redesign by increasing the size of beam. Okay, so kalau satisfied, you just mention it's satisfied. Kalau tak satisfied, so you have to mention it's not satisfied, need to redesign, okay, according to the size and so on. Okay, so that's 6 examples for the beam. We have another one, right? Examples for the joist here. Okay, this one for the joist. So what's the difference for this the joist here is this is the beam, this is the main beam. So kalau buat 3D so this is the main beam here. Well, this is the joist. So there will be more than one joist, okay, with the spacings of 400 mm. Okay, so there will be a joist with spacing here 400 got one joist, and then another 400 got one joist. Okay, so this is the part that you have to design according to these examples. the floor spanning 3.8 meter center to center. So that means this is the L effective, which is also the length for the joist, right? 3.8 meter here. What else? It give a imposed load, which is a QK. That means you have to calculate what's the maximum loads. Okay. Including self weight. While this is the dead load, this is GK. Carry out design checks to show that a series of these rectangles, right? Strength group SG4 is a SON, standard grade timber, which is STD. Under dry condition, is suitable or not? Okay, so again, it's same here. You have to extract all the data and then do the load analysis. It gives a dead load and then imposed loads. Okay, so what's the total load? Dead load plus the punya live load here, and then you have to multiply by its spacings, right? 0.4. Ni so kalau lihat kat sini, so this is if I draw back, this is the joist. Okay, so this is the joist here with the spacings of 400. So the loading, okay, for this joist is 0.35 plus 1.5, which is 1.85. Okay, 1.85 here. This one also same. So you have to multiply half of this area. Okay, half of this area. Okay, that's why you will get 400. And then this one is a kilonewton per meter. I think there's something wrong with this one. Kalau you darab 1.85 multiply with 0.4 here, can you get 0.74?
Yes.
So you don't have to multiply with the length. Okay.
Okay.
Okay, so just multiply according to its base, because half of it distribute to this joist and half of it distribute to this joist here. Okay, which is 1.85 actually is a okay, it's mentioned about the floor. The floor is subjected, so that means that is the load for the floor. It's not from the joist. So 1.85 is actually distributed all over this flooring system. So that means each of these joists will get this value, which is 1.85. Half of it transferred to this joist, half 1.85 transferred to this joist. So that's why each of the joists will carry this loading 0.74 kilonewtons per meter. Let's say this is the joist here with the length of 3.8, so 0.74 kilonewton per meter. So dah dapat loading for the joist. Okay, and then the next step, so just same as previous examples, you have to list out all the key factor. Okay, so because of this part have a sharing system, so that's why K2 is equal to 1.1. Okay, so is it comply with the sharing system or not? You have to check, is it the spacing is should be less than 610. That's mean it should be close enough. It should be short spacing kan. Barulah namanya sharing. So this one 400. So it complies with the requirement of sharing system. And then elements more than 4. Okay. So that's why K2 is equal to 1.2 here. Okay, for the sharing system. Okay, then apa lagi? Any mention about load durations? Dia tak cakap is it long durations or short durations, tapi dalam solution ni it give sharing K1 is 1.0, that means long duration. Some of the informations not enough, right? Okay. So and then you can check everything lah. Sama lah, no notch. So that means K4 1.0 is a rectangle section, and then check dia punya depth, is it less or more than 300 in order to know the K6 value. Otherwise you have to use the equations. Okay, so this is all the same. Okay, a step which you have to do some revisions. Okay, finish for designs beams. That also seems if you want to design the joists. Okay, so please do your revisions on it. Again, I repeat, that's the design for timber by hook or by crooks normally will be included in the exams. Okay, kalau concrete design concrete beam tu memang of course lah. Okay, but design of timber also will be included in the exams. Okay, okay, then we go for part 4. Okay, for the columns design here. This also the same things for the columns. Okay, but the things that you need to know is about the lengths of the columns. Kan? Kalau columns, it has a different conditions, top and bottom of it. Is it fixed, or pin fixed, or roller fixed? So it depends what the condition of that column, what connections of that columns. So kalau fixed, so this is the L effective. Okay, L effective for the column, which is L effective is equal to 0.7 L. Okay, which is you also can refer in the tables 9 here. Okay, if free on top of it but bottom is a fixed, macam bendera ke kan, which is free on top of it, there's no restraints directions. So L effective is equal to 2 L here. Okay, this is the length. Okay, this is the length. So why is not fully considered here? Because of this top and bottom, it's fixed. It restrains fully fixed on top of it. So that means there will be a zero moments, and then it becomes bending and becomes a zero moment. So that's why this is the effective length that is equivalent to 0.7. Okay. Kalau pin, there's no restraint on top of it, so that's why it's fully bending from top to the bottom, from end to end. So that's why L effective is 1.0. So that is about how the portions is different according to the restraints and conditions for the columns. So from the L effective, it will be used in order to calculate the slenderness ratio, okay, for that column. So columns more related to how the slenderness ratio for the columns, which is slenderness ratio is equal to L effective divided by I. So I here is the radius of gyrations. So this is equation for the I. Okay, the slenderness ratio have two considerations: should not exceed 180 or should not exceed 250 here. So any in terms of related to its conditions, okay, for slenderness ratio not exceeds 180, that means slenderness ratio not exceed 180, while this is slenderness ratio not exceeds 250 here. For any compression member, for any column carry, dead and imposed load, okay, other than load resulting from the wind, okay, you can refer the details. So for slenderness ratio not exceed 250, for any column, any member subjected to tension or combined tension and bending, okay, arising from dead load and imposed load. So that means there is two slenderness ratio here according to the conditions of that compression member. Okay, so this is another modification factor for the columns, which is K8. Okay, for this K8, this is all the equations, formula, additionals for the columns, which is you also can refer table 10. Kalau pergi dekat table 10, okay, so this is the table 10. Okay, for modification of K8 for compressions member. Okay, so you can see here the slenderness ratio, which is slenderness ratio 5 or 10, so up to 250. Because of slenderness ratio should be less than 250 or slenderness ratio less than 180, right? So that's why in this table, the maximum slenderness ratio is 250. Okay, so this is a column for modulus divided by stress compressions parallel to the grain here. So you have to divide it in order to know what's the value. Okay, and then this is the equivalence L effective divided by B here. All right, so this is the permissible stress, okay, which you need to which you need to calculate the value, okay, for the permissible stress, which is the compressions parallel to the grains multiplied by K1. So if you look at this timber here, okay, so this is the direction for the compression. So that's why we need to know what's the compression parallel to the grain. For the beams, this is direction for the compression. So that's why we need to know what's the compression's stress perpendicular to the grain directions. Okay, so that's why for the compression member, we will refer compression's stress parallel to the grain. this is E minimums, okay, and then slenderness ratio. Then N here is a 0.005 slenderness ratio. Okay, so you need to list out all the value here before you can replace and know what's the K8 value. This is the tables, and then this is how the steps, okay, for the columns. Okay, first you have to calculate macam biasalah what's the applied compressive stress, which is stress is equal to P divided by A. And then the permissibles to compare, okay, with the applied axial compressive strength here. It has two permissibles here according to the slenderness ratio. Is it slenderness less than 5 or more or equal to the 5, which is if less than 5, it will consider K1 and K2. Kalau more than 5, okay, so you have to consider with additional of K8 for the modifications factor. Okay, all right, so for the loading, so there are many types of loading, how the load that is pointed to that columns. So if pointed exactly at the center of the cross section, beam cross section, so that means moment is equal to 0. If have a eccentrics that have a EY here, have a distance from the center to the point load here, so the moment is equal to the P load multiply with the EY. Okay, moment multiply with the directions here, EY. So same goes kalau directions in x-axis, so moments which is load multiply with the distance in EX directions here. So if the loads in between x-axis and y-axis, so there will be a two moment here, okay, PEY and PEX here. Okay, so and then this is another trackings here, okay, so which is you have to this for member which are restrained at both ends in position but not in direction. Okay, so this is another checkings, okay, which is you have to consider the bendings parallel, the compressions are parallels, okay. It should be less than 1 here, okay, should be less or equal than 1 here, which is from all of these equations. So you can say use of all of these listed equations lah, okay, before you can replace in this formula. So banyak formula kan, so that is about the timber process, especially for the columns here. Okay, dalam author, it give one examples. Okay. Which is actually you can go through, okay, is the same process for the timber structure. So kalau lihat kat sini ya, dia mention about dry sun. Okay, make sure you refer the correct tables, okay, according to the conditions, according to the data given. Nyatuh timber, dia tak bagi SG berapa, SG1, SG2, no. It just give a species. So you have to check in the table what the SG, what the standard grade or strength grade for nyatuh timber. Okay, standard grade at 19% of moisture content. So it mentioned at 19%. So that means this is a dry timber. 4 meter in length. So the length of these columns is 4 meter. The column is restrained at both ends in position but not in direction. So that means you have to use checkings for these conditions. Okay, checking mana tadi? This one, this is for checking if mentioned restrained at both ends. So restrained at both ends here. So both end is restrained here. Okay, so determine an appropriate size of rectangular cross sections. So rectangular cross section. So it not give a size here. You have to propose the size, but it should be rectangles, shapes, so that the axial long-term load of the column is more than 25 kilonewton. Then check the column is adequate or not to resist long-term axial load. Okay, long durations here with the load of 12 kilonewton and the bending moment. Actually, it already give the load and already give the moment. Okay, about its x axis. Okay, so same, you have to accept everything, and then this is the cross sections of the beams here. So try size, you have to propose the size. How to propose the size? You have to check in the tables, right? So kan ada sizings for the timber. Kat mana size dia? So you can see here all the size. Okay, you can select what the size. Okay, you can try any size. Okay, dekat sama juga dekat part tu. So this is the examples column sizings. Okay, from this size you can determine the punya area, what the IXX, what IYY, and then radius of duration, and then sections modulus here. Check the punya slenderness ratio, and then keluarkan the punya grade stress. Okay, it mentioned about bending, compressions. Okay, list out everything of its K factor or modification factor. Okay, and then from the tables you can come up what's the E value divided by the compression parallel to grains, what the slenderness ratio. Okay, might be some of it. If not the value not in the table, you can do the interpolations and so on. Okay, so this is how the to know what's the K8, because some of the equation include the K8, right? Okay, according to the slenderness ratio. Okay, everything's sama je, which is you have to compare the applied and everything. Okay, which is I hope you can go through for the column also. So the same steps here, which is apply, and then you have to compare with the permissibles, and then lastly you have to do the checking because of restraint conditions. That is the only additionals, okay, for the columns designs. All right, so I think that's it for the timber designs. nampak macam apa ni complicated, right? Because of many reference need to do in the apa ni, in the tables. Okay, but I can say that's kalau you betul-betul faham, actually the timber designs quite simple. Okay, compared to the concrete, because it's just a natural construction materials. All the strengths just refer to it beam sections. Okay, there's no reinforcement inside it, just according to the strength of the timber, according to its grains directions, what the strengths, according to the parallels or the perpendicular grain directions. Okay, so that's it for the timber. Any questions? I will turn on the attendance. So that's mean we have another one. Topics. Last topic will be delivered by next week's on pre-stress. That one just introductions about the pre-stress. Okay. Speech up here. This is sections 5. Any questions? You can submit attendance in the auto system. Don't forget about it. And then one more thing, I just update the due date for the projects in the auto. You can refer. Kesian ke korang, so I extended to week 16th about at the due date on 5 July, I think. So I think it's sufficient enough. Is enough time for you to complete your projects. Okay? Is it okay? Okay, so if you don't have any questions, I'll stop the class. See you again next week for our last class. Bye semua.
Thank you, Doctor.
Okay, doctor. Thank you, doctor.
Thank you, doctor.
Thank you, doctor. Thank you, doctor.
Thank you, Doctor.
Alright.